Hello. Today we're going to talk about testing a difference in performance, which is also testing a difference in proportion. So think about if you are talking about the proportion that you get an A in your math test and the proportion that you get an A in your science test, and you're asking if you actually do have a better ability to take tests in math than you do in science. So looking at an example, we have on August 8th, 2009, Nick Swisher. He hit 3 home runs at home and 15 on the road. And we want to see if he has a greater ability to hit home runs on the road. So this question right here is called our question of interest. It actually helps us when we're trying to write our hypotheses. So whenever you write your hypotheses, you've got something called the null hypothesis, which signifies as H naught for notation. And then you have also something called the alternative hypothesis. And that notation is HA. Okay, and the null hypothesis is always a statement of no change. So if we were testing to see if he has a greater ability to hit home runs on the road, then the statement of no change would be that Nick Swisher has the same ability to hit home runs at home and on the road. Okay, long sentence. All right, and then the statement of change would be the greater ability on the road. So we're kind of just taking the question of interest and forming that into a statement. So Swisher has a greater ability to hit home runs on the road. And what I'm looking for is for you to tell me who you're talking about, who your subject is, your statement of ability, whether that's the same ability or greater ability, and then what they're actually doing in context. And when we talk about in context, that's saying hitting home runs or taking a test. So being able to describe what the situation actually is. All right, so after we state the null and the alternative hypothesis, we have to determine if we can reject one of those hypotheses. Okay, so you always want to assume the null hypothesis before you can actually determine the alternative hypothesis. Think about if you assume innocence before you're proven guilty. So if you were a jury member, you always assume that the defendant is innocent before you can actually prove using data or using evidence that someone is guilty. And the same is true for when we're doing hypothesis testing. So to set up the hypothesis test, you have to calculate something called a test statistic. The test statistic tells me the differences between the home performance and the road performance. And you want to see kind of what that greater proportion is, and that's the proportion that you're going to be testing against your two hypotheses. So the first thing is you're going to be looking at this two-way table, and we already kind of talked about how to make the bar graph using the two-way table, so this should be pretty quick. Winning percentage at home, how many did they win? They won 6 out of how many that total they played at home, which is 8 or 75%. On the road, they hit 3 out of 8, which is, calculator, 37.5%. So the difference is based on what you say your alternative hypothesis. So if we're asking if the Cardinals have a greater ability to win at home, then we're going to do 75 minus 37.5. But if we were to ask if they have a greater ability to win on the road, then we would do vice versa, 37.5 minus 75. So your test statistic is going to be 37.5%. And we're going to test this against our two hypotheses. So we refer to this test statistic 37.5. It's the test statistic that we found with evidence, and we're going to try to test it against our hypotheses. We want to see how likely it is to get at least 37.5 or more, so at least 37.5, assuming that the null hypothesis is true. So that's a big proportion, or that's a big section right there. That's a great line. You always assume that the null hypothesis is true. Again, you assume innocence until proven guilty. So we want to test to see if 37.5 comes up a lot. If it comes up a lot, that's random chance. So before we were looking, if there's a dot above the line, that's random chance. But now we are starting to define how much random chance can we use. Is 1% enough to really say that there's a change in ability? Or is 1% enough to say that there's the same ability? So we're testing to see if 37.5% comes up a lot, and we'll talk about what a lot means in the next video.